Synthetic division. In previous lecture, the synthetic division, we have seen how to perform the polynomial division, higher order polynomial divisions if the divisor, if the divisor is a linear expression which is in the form of x minus a. Okay, so here we consider one example in the previous lecture. Please watch the video. Just I am rewinding the process what we did in the previous lecture about the synthetic division if the divisor is a linear expression which is in the form of x minus a or ax plus b. Okay, so here the given polynomial equation is divided by x minus 4. So we have did as first list the coefficients. Okay, list the coefficients in a row. So here we have listed the coefficients as 1, minus 6, 3, 26 and 24, minus 24. After that, to the left of the vertical, okay, right, draw a vertical line to the left of the leading coefficient. Okay, to the left of the leading coefficient. Next, to the left of the leading coefficient, write down the divisor x value. We have the divisor is x minus 4, equate that to 0, and x is equals to 4. Write down the divisor to the left of the leading coefficient in the same row 1. Okay, after that, the first under the first the leading coefficient, under the leading coefficients in the first column, make it as a 0 and add the elements under the first column. Here we get the sum. Now this sum has to be multiplied with the divisor x value 4. The resultant has to be written in the next column in second row. Okay, resultant has to be placed in the next column in second row, and now the column element, second column elements is added. Now the sum is again multiplied with the divisor x value that is listed in the next column. Okay, in row 2, the next column, and again we add the third column elements. Then again we get the sum. Again this sum is multiplied with the divisor x value that is listed in the next column. Okay, under the coefficient of the next column. Again we add the column elements. Then we'll get up to the last column. Okay, this has to be repeated. Multiply and add has to be repeated until the last column. Under the last column, the column resultant is considered as a remainder. The remaining elements, okay, the remaining sum elements in row 3, okay, remaining sum elements in row 3 are considered as the coefficients of the quotient, where from the right to left this has to be taken from the coefficients of x power 0, x power 1, x power 2, x power 3. So now we can generalize this as if a p of x polynomial is divided by some x minus a, okay, is divided by x minus a, and we are getting the quotient as q of x and the remainder as r of x. Generally this r of x is constant if we divide with the divisor of a linear expression. So we can write p of x equal to x minus a into the quotient q of x plus r remainder. Okay, plus r remainder is a constant. This is the way of performing the synthetic division if the divisor is, okay, if the divisor is a linear expression. Okay, now in this lecture we are going to learn the same synthetic division process if the divisor is a quadratic divisor. If the divisor is a quadratic divisor, so that means if the divisor is in the form of px square, okay, some x square, sorry, if the divisor is in the form of a quadratic expression like x square minus px minus q, okay, if the divisor is in this form, then how to perform the synthetic division we will understand with one example. Now consider the question. Here the question is given that find the quotient and remainder. Okay, just over here. Okay, find the quotient and remainder when the polynomial 2x power 5 minus 3x power 4 plus 5x square 5x cube minus 3x square plus 7x minus 9 is divided by the quadratic divisor x square minus x minus 3. So now we have to always compare the quadratic divisor with the standard form as x square minus px minus q. Okay, so now if we compare with the standard form x square minus px minus q, which is an important one. With the quadratic divisors are always compared with the standard form as x square minus px minus q, and here given the divisor is the quadratic expression x square minus x minus 3, then p is equal to 1 and q is equal to 3. Now how to perform this division? Let's consider the given polynomial is some expression as the polynomial as p of x. Okay, so now if we divide with the quadratic expression x square minus px minus q, okay, let's consider the quotient we are obtaining it is as q of x, and the remainder we are obtaining it is as r of x. Okay, just compare with the previous polynomial. What is the polynomial division of a linear expression with x minus a? Then we are getting the quotient and remainder. Okay, quotient and remainder, where p of x is an nth degree polynomial. Okay, x power n polynomial, nth order polynomial. Then we are getting the q of x as x power n minus 1. Okay, x minus n power 1 degree n minus 1 power polynomial. Okay, now here for this case, okay, for this case, and whereas r of x is a, the remainder over here it is a constant term, that means x power 0. Okay, but in this division with the quadratic divisor, in this division if the p of x is an x power n, okay, highest degree of x power n, then the remainder of q of x, sorry, the quotient of this q of x, okay, is of n minus 2. Okay, power is of n minus 2 power, whereas the r of x is in the form of a linear expression, that means r1x, okay, r1x plus r2. Okay, so we get here the constant term and x power 1 term also. Okay, now we will understand with by solving this given example. Okay, the first thing we have to do is write down the coefficients in the decreasing powers of the variable in a row. List out the coefficients in a row. So what it is: 2, minus 3, 5, minus 3, 7 and minus 9. Okay, so in previous lecture, if it is divided by a linear expression x minus a, we have only one row, okay, under the coefficient column. Okay, we have only one row under the coefficient column, but we need to give some space for two rows under the coefficient columns. Okay, under the coefficient row we need to give two rows space. Okay, next draw a vertical line and horizontal line allowing some space between them. Okay, to the left of the leading coefficient, okay, to the left of the leading coefficient is x power 5 coefficient is 2. To the left of the leading coefficient draw a vertical line, and under the third row draw a horizontal line. Okay, in previous process, to the left of the vertical line in the first row itself we have written the value of x minus a, that means x is equals to a to the left here. But here in the left of the vertical line in second row and third row, okay, in second row we have to write the value of p, and in third row we have to write the value of q. Now I am writing value of p is 1 over here and value of q is 3 in the next row. Okay, value of p is in the second row and value of q is in third row. Okay, after this another important point here is, so in previous division with x minus a, under the first column only we have written the 0, but here under the first column, okay, under the first column we have to write the 0, and in row 3 also, okay, in row 3 the second column also we have to place 0, okay, which is the important one. So in row 2 first column, and in row 3 the first two columns has to be placed with 0. And another important point, in row 2 under the last column also we have to write the 0. In row 2 under the last column also we have to write the 0. Okay, students, are you getting? So under the first row, okay, under the first column, write the two zeros. In row 3, under the second column, also write the 0. In row 2, under the last column, okay, in row 2, under the last column, write the 0. Okay, after this, the first thing we have to do is add the first column elements. Okay, add the first column elements. 2 plus 0 plus 2, and what we are getting, which is as 2. Okay, 2 plus 0 plus 2, which is as 2. After this, now the sum is 2. Now this sum is multiplied by the left, what it is, in the second row, multiplied by the second row to the left of the vertical line element, that is the p value 1. Okay, so now this 1 has to multiplied by 2, and the resultant is placed in the second row. Okay, we are multiplying with the second row element, then the resultant is also placed in the second row. 2 into 1, we are making this as a 2. Okay, 2 into 1, we are putting here, it is as a 2. Okay, now after this, already in the third row, in the second column, third row, it is 0, we already placed. Now the add the, okay, after this add the second column elements. Okay, so if we add the second column elements, what we'll get over here, it is as minus 3 plus 2, we get as 1. Okay, minus 3 plus 2, we get as 1. So now we got the sum under the second column. Okay, the new sum element is obtained. Okay, now this new sum element has to be multiplied by the p value 1. Okay, it has to be multiplied by the p value. Now we are multiplying under the second row. Then the resultant has to be placed in under the next column, second row. Okay, under the next column, second row. What it is, 1 into minus 1, then it is minus 1. Okay, minus 1. So now under the third column, how to obtain under the third column? So the before the sum, what is the before the sum? 2. Okay, now this 2 is multiplied the third column factor, what is 3. Now 2 into 3, now these are to be multiplied, and the resultant has to be placed, the multiplied result 2 into 3, the multiplied resultant is 6. Now this 6 is placed under the third row under the second column, in third row under the third column. Okay, now add again the columns. Okay, if you add the column, then what you will get the result, 6 plus 5, 11 minus 1. Okay, we are getting the sum as 10. Okay, we are getting the sum as 10. Now next, what we have to do, the new result 10 again multiplied with the 1, the before result minus 1 is multiplied with 3. Okay, now the new result 10 is multiplied with 1. Okay, 10 multiplied with 1, and the resultant is placed under the next column. Okay, next column in row 2. Okay, next column in row 2. Now here it is, which is 10. Okay, next before the sum, that means the minus 1. Minus 1 is multiplied with 3. Okay, minus 1 is multiplied with 3. Now we are in the third row. Now this is placed in row 3. Okay, this is placed in row 3. Then the resultant equal to 4. Okay, resultant equal to 4. And next the new result is again multiplied with 1. Before the result is multiplied with the 3. Now 4 multiplied with 1. Okay, this multiplied result in the next column, second row. So which is equal to, we get as 4. Okay, we get this is as 4, and before result, before sum, 10 multiplied with 3. Okay, then sum is multiplied, it is in the third row, the next column. So what it is, 30. Okay, resultant equals to 41. Okay, resultant equal to 41. Okay, and here already this element is put 0 in the next column. Okay, next column row 2, the element is put in the 0. So that means here the 41 is not multiplied with the 1, but the before element 4 has to be multiplied with the 3. Why? Because 41 is multiplied 1, but we already put here it is as a 0. So now before the element, that means the 4 has to be multiplied with 3 and that has to be put in the row 3. Now this 4 multiplied by 3. Okay, now this 4 multiplied by 3 in third row, it has to be placed as 4 into 3, 12. Okay, it has been placed as 12 and add. Okay, every time after getting the column elements we need to add. Okay, now add the last column, then we'll get this is as a 3. Okay, then we'll get this is as a 3. And just before the case we have discussed that if x power n divided by x power 1 factors, that means x power 1 factors, then we'll get the quotient as x power n minus 1 and remainder as a constant. Okay, remainder as a constant. But here the x power n is divided by x square. Okay, quadratic expressions. Okay, x square, then we get the quotient q of x. Okay, the quotient as x power n minus 2 and remainder in the form of r1 x plus r, that means x power 0 into x. And here we have to take the last two terms in the sum result as remainder. Okay, as remainder. Okay, the last two terms has to be taken as a remainder and remaining all sum elements. Okay, remaining all sum elements are coefficients of the quotient polynomial. Okay, these are the coefficients. 2, -1, 10 and 4 are coefficients of the quotient polynomial. Okay, quotient polynomial. Okay. So now we can write the remainder as, so what is the remainder? So this one is x power 0 term and this one is x power 1 term. So that means the remainder r of x can be written as 41x plus 3 into x power 0, which is the remainder. 41x plus 3 is remainder. And what is the quotient? So the quotient is x power 0, x power 1, x square and x cube. So we can write the quotient as, okay, I am writing in a box as, the quotient I am writing in a box as 2 into x cube minus 1 into x square plus 10 into x plus 4. Okay, 2x cube minus x square plus 10x into 4 is quotient q of x, where the divisor is x square minus x minus 3. Okay, finally we can write the given polynomial equation as, what is the polynomial equation? 2x power 5 minus 3x power 4 plus 5x cube minus 3x square plus 7x minus 9 is equal to, one factor is the given, divisor is one factor, that means x square minus x minus 3 is one factor. It is multiplied by the quotient. What is the quotient? 2x cube minus x square plus 10x plus 4 plus remainder. What is the remainder? Remainder is 41x plus 3. Okay, 41x plus 3. Now if we simplify this RHS, we will get the required result. So now I can write this is as, so if a p of x is multiplied by x square minus px minus q, then the p of x can be written as x square minus px minus q into quotient q of x plus r of x. Okay, where this quotient, what is this given polynomial is if having the x power n, then we get this as x power n minus 2 quotient. Okay, here we'll get the polynomial as a x power n minus 2. Okay, just observe over here what it is. In the given question we are having x power 5 as a p of x and x power n minus 5, n is equals to 5 and 5 minus 2 means x power 3, then we are getting the quotient as x power 3 polynomial. Okay, I think you understand how to perform A synthetic division if a divisor is given as a quadratic divisor or a trinomial function. Okay, here the three nominals. One is x cube, x square, x3. Okay, if the divisor is a quadratic expression or a trinomial function. Okay, now we will understand the synthetic division with the quadratic divisor with another example. Here the quadratic divisor what is x square minus 7x plus 12 and the given polynomial x power 4 minus 11x cube plus 44x square minus 76x plus 48. And what is the first step? We have to write the quotients of the given polynomial in a row. 1 minus 11 44 minus 76 48. Okay, so this is the first step. Then draw a vertical and horizontal line giving for space for two rows. Okay, let row 2 and row 3, where row 1 is a coefficient row, coefficients polynomial row. After this, so now these two, okay, first column, under the first column make 0, two elements as 0, under the first column row 2 element and row 3 element 0, under the second column row 3 element is 0, and under the last column, okay, in last column in row 3, under the last column row 3 element make it as a 0. And now compare with the standard form of the quadratic divisor. X square minus px minus q, x square minus 7x, x square minus 7x plus 12, that p equal to 7, q is equal to minus 2. Write down the p in row 2, okay, and q is minus 12 in row 3. Okay, after this add the first column elements. Okay, add the first column elements, we will get it as a 1. Now this 1 to be multiplied with 7. Okay, 1 and 7 resultant in the second row, 7. Okay, 1 and 7 resultant in the second row. So here the again, now after getting this add all the second column elements, then we get this is as a minus 4. Okay, after minus 4, yes, after minus 4 the new sum, okay, minus 4 multiplied with 7 and the resultant is in second next column second row. Okay, 7 minus 4, that means minus 28. Okay, here we have minus 28. So before sum, what is 1? 1 is multiplied with this minus 12, then the resultant is in next row, third row. What it is? 12 into minus 12 into 1, which is minus 12. And now add the column elements. If we add all the column elements, we will get the result as 4. Okay, add all the column elements, we will get the result as 4. Okay, next the new sum 4 is multiplied with 7. Okay, the new sum 4 is multiplied with 7, the resultant is in now the second row. What is 7 into 4? 28. Okay, 7 into 4, 28. The before sum minus 4 is multiplied with minus 12, the resultant is in third row. What is the resultant over here? Is 12 into 4, 48, and the sum we get it is 48 plus 28, 76 minus 26. So add all these column elements, you will get the sum as 0. So after getting 0, the new sum 0 is multiplied by 7, but already it is 0 placed in the second row. So that means here no multiplication with this result. And the before result 4 is multiplied by minus 12. Okay, 4 is multiplied by minus 12 and the resultant, this has to be placed under the third row, minus 48. Okay, minus 48. Then the resultant, add these elements, then the resultant is 0. Okay, while we are doing with the quadratic divisor, the last two elements are taken as, okay, the last two elements are taken as remainder. Okay, the last two elements are taken as remainder. The remaining elements are taken as coefficients of the quotient polynomial. This is x power 0, x power 1 and x square. Then the quotient q of x equal to x square minus 4x plus 4 into x power 0, and remainder r of x is equals to r1 into x, 0 into x, 0. Okay, this means 0 into x plus 0. Okay, why? Because this is x power 0 term, this is x power 1 term, then the remainder equal to 0. Then we can write the given p of x equal to quadratic divisor x square minus 7x plus 12 into quotient q of x plus r of x. So that means here we can write this as given 1. So I am writing over here x power 4 minus 11 x cube plus 44 x square minus 76x plus 48 can be written as divisor x square minus 7x plus 12 into quotient x square minus 4x plus 4 into remainder is 0. Okay, then if we multiply these two, we'll get the LHS. So I think you understand in this lecture how to perform the division of the polynomial if the divisor is a quadratic divisor. Thank you. In the next lecture, we'll come with more problems to understand this what it is polynomial division. Thank you.